Welcome to the Happy Euclidean Geometry Friday series, my Level 7 Pioneers. In this series, as I've stated on my previous video, we are planning to make you feel more comfortable with Euclidean Geometry. I want you to excel in Euclidean Geometry because I feel like it's the most important topic, and I feel like most of our pioneers are struggling with it. But I find it very simple. So by the end of this video, you'll be able to solve any Euclidean geometry question that you want to solve. So without further ado, I'm going to link a playlist on our screen right now whereby I am teaching all the theoretical part that you need to know about Euclidean geometry. And on our description box below, I'm going to link two crucial videos whereby I'm summarizing Euclidean geometry. By the end of those videos, you are going to be my level 7 pioneer. Right. So remember our 3 golden rule. Firstly, we are going to read the statement and understand the statement. And if there's anything that is in our statement and is not on our diagram, you are going to add it on our diagram. And our second step, our second golden rule actually, we are going to analyze the diagram before we even look at the questions. And then our third one, we are going to read the question and answer them. That's when I'm going to teach you how to tell a story. So, right, let's read the statement. In the diagram below, O is the center of the circle, right? P, Q, R, and S are points on the circumference of the circle. TOQ is a straight line such that T lies on PS. And then they are saying PQ is equals to QR and Q1 is equals to X. So I think the most important things that we need to note on our statement is only these things. And if we are looking at the statement and the diagram, everything is there. There's nothing to add. Right. So let's analyze the diagram. I like to encourage my students to firstly attack those easy things on our diagram. Immediately when they say O is a center, immediately when you see the word center, you must think of semicircle, angles in a semicircle, or you need to think of the angle at the center is 2 times the angle at the circumference, and you also need to think about the radiuses, isn't it? So here is a straight line from the center to the circumference. OQ is a radius, and OQ is going to be equals to OR, isn't it? I think that is the most simple things that we can easily identify from our diagram. So I was talking about the angle at the center is twice the angle at the circumference. So this is the situation, isn't it? We are having our second theorem, right? The angle at the center is equals to 2 times the angle at the circumference. Right. Let's continue with our radiuses, isn't it? So we know that if we are having a triangle that has 2 equal sides, that means we are dealing with an isosceles triangle. And the most important property of an isosceles triangle is that base angles are equal, isn't it? And then we can clearly note that down. And then from this triangle, guys, we can try to find angle O1. How can we do that? We can do the sum of angles in a triangle, isn't it? So if we do the sum of angles in a triangle, we know that we are going to be left with O1 is going to be equals to 180 minus by 2x. So you will see how we got 180 minus by 2x because we are still going to be solving this thing. And obviously, if this is 180 degrees minus by 2x, that simply means our P1 it's going to be 90 degrees minus by x because we are going to divide by 2 throughout, isn't it? Right. And then there is this very important thing that they told us on our statement is that PQ is equals to PR, right? So PQ is this one, is this line, and QR is this line. And then we can see that we are forming a triangle, isn't it? So that means this angle is going to be equals to 90 minus by x. So if you're having any questions, please post them on our comment section below. I'll make sure I'll get back to you. Right, so we need to highlight this on our diagram with a colored pen. So here is going to be 90 minus pi x. And then another thing that I want my level 7 pioneers to easily note from a diagram that is given, any four-sided shape that fits perfectly on our circle is a cyclic quadrilateral. The vertices of this four-sided shape must be on our circle, right? And then that means we can conclude that we are dealing with what? With a cyclic quadrilateral, right? So what are the properties of a cyclic quadrilateral? That's the video I'm linking right now on our screen, whereby you are going to learn about all the properties of a cyclic quadrilateral, how to identify it as well, right? So let's go to our next unknown. So in this triangle, right, you remember that we ended up having only two angles. Now we can have angle Q, right? You are going to say angle P1 plus angle Q plus angle R is equals to 180 degrees, and your reasoning, are going to say sum of angles in a triangle, and then when you do your math, you are going to get 2x. And then after getting 2x, you are going to say 2x plus you are going to say angle Q plus angle S is going to give you 180 degrees. That's one of the most important properties of a cyclic quadrilateral. So you are going to be getting this angle is going to be 180 degrees minus pi 2x, right? So right now, I feel like our diagram is complete, right? I feel like we've analyzed anything that we need to analyze. Then we can go and tackle our question. Let's start by 8.2.1, right? They're saying calculate with reasons angle P1 in terms of x. So we already have angle P1 in terms of x. So now the problem becomes it comes to be, how do we write the story? Remember, guys, we first identify the radiuses, and then we identify angle R1, and then after identifying angle R1, we identified angle O1, and then that's when we were able to find angle P1. So all of that you must include on your answer. You must include it on your story, isn't it? So my story is going to be starting like this: QO is going to be equals to OR, right? And then I'm going to tell the person who is marking my paper that the reason is going to be radi, right? And then after that, you are going to say angle Q1 is going to be equals to angle R1, which is equals to X, right? And then here, your reasoning, you are going to say base angles of an isosceles triangle, right? And then you are going to say in triangle QOR, angle O1 plus angle Q1 plus angle R1 is going to be equals to 180 degrees. Your reasoning, you're going to say sum of angles in a triangle, right? Remember, guys, if you are having any question, please post them on our comment section below. And if you find this video valuable so far, hit that like button. Right, O1 is what we are looking for, and Q1 we have it, which is X, and R1 we have it again, it's X, and then it's equals to 180 degrees. And then we are going to add like terms. X plus X is going to be 2X. And then when you transpose to the other side, our answer is going to be 180 minus by 2X. And then after here, we are going to say O1, angle O1 is equals to 2 times angle P1, right? Your reasoning, you are going to say angle at the center is equals to 2 times the angle at the circumference. And then you are going to substitute. So angle O1, we know it's 180 degrees minus by 2x is equals to 2p1. And then we are going to divide by 2 both sides, because we are not looking for 2p but for angle P1. And then 180 degrees divided by 2 is going to be 90 degrees. And then 2x divided by 2 is going to be x. So that's how we express angle P1 in terms of x. So I'm not saying this is the only way. We can find another level 7 pioneer solved this question in another different manner. But what is more important is to find the very same answer. If the answer is not the same, that means one of us is incorrect, right? So let's go to our next question. That's the beauty of Euclidean geometry, actually. We can solve the same question using different methods, but we have to come to the same answer. If not so, that means one of us is what? Is incorrect. So our next question is that show that TQ bisects PQR. Remember, guys, this is what I've taught you on our last lesson. I will link the link to our last video, our first episode of the Happy Euclidean Geometry Friday series, right? So I said to you, when you see the word bisect, it simply means that this line is cutting the other line in two equal parts. If it's not a line, it's going to be an angle. So in this case, we are having an angle being cut into two equal parts, isn't it? So they are asking us to prove that line TQ, this line, is bisecting this angle, which is angle PQR, right? So how do we go about solving that? Remember, we found that angle Q is equals to 2x. We know that if angle Q is equals to 2x and we know Q1 is x, that means we have proven it. So to answer this question, we have to find the whole angle. So we are going to tell our examiner that in triangle PQR, we are having angle P1 plus angle R1 plus 2 plus angle Q being equals to 180 degrees. Our reasoning, you are going to say sum of angles in a triangle, right? And then you are going to say P1 is equals to 90 minus by x. Angle R1 plus R2 is going to be 90 minus x again plus angle Q is equals to 180 degrees. So remember, from here we are going to add like terms. 90 plus 90 degrees is going to be 180 degrees. Negative x plus negative x is going to be negative 2x plus angle Q is equals to 180 degrees. And then from here you are going to transpose. So when we are going to transpose, this 180 degrees is going to cancel this other 180 degrees. And then our angle Q is going to be positive 2x. Right. From here, you can tell the examiner that you know that angle Q is equals to angle Q1 plus angle Q2. You can just give a lousy reason. You can say it is given because it's given from our diagram that Q1 plus angle Q2 is equals to angle Q. So we know angle Q is 2x. Angle Q1, we are given that is x plus Q2. We are looking for Q2. And then when you transpose here, your angle Q2 should be equals to x actually. And then you can say, therefore, angle Q2 is equals to angle Q1. And then you tell the examiner, therefore, TQ bisects angle PQR, isn't it? So if you want to give a reason, you can say angle Q2 is equals to angle Q1. So that means this angle is equals to this angle, and that means line TQ is cutting angle PQR into two equal parts. Right. So let's go to our final and last question. Remember, guys, the genesis of this video is from TikTok, And if you are from TikTok, please shout on our comment section below. I'll make sure I take a notice of you. So we started with this question from a long way, from the village of TikTok here, and then we are in the suburbs of YouTube now, right? So our last question, they are saying show that store is a cyclic quadrilateral, not store, guys, STOR, isn't it? So STOR, we must prove that this is a cyclic quadrilateral. Remember, guys, I linked a link on our screen. I'll link it again if that's possible. I'll link it again so that we can learn all the properties of a cyclic quadrilateral. So a cyclic quadrilateral has two main properties. You are going to say the exterior angle, which is O1 on this case, must be equals to angle S. But we can see that we have already proven this thing, isn't it? So how did we go about that? We said angle Q plus angle S is equals to 180 degrees. Your reasoning, you're going to say opposite angles of a cyclic quadrilateral are supplementary. So which cyclic quadrilateral I'm talking about is that one I indicated at the beginning of this video, isn't it? I said to you PQRS is a cyclic quadrilateral. Why? Because it's a four-sided shape that fits perfectly on our circle, meaning that their vertices are at the circumference. So I'm talking about that cyclic quadrilateral because I normally see many students, they will use this STOR cyclic quadrilateral as a reason, but that's not a reasoning, guys. That's just, I don't know what to say, but that's what we are trying to prove, isn't it? Right. So angle Q, we are having 2x, angle S, not S, angle S is equals to S, is equals to angle S actually, 180 degrees. Then angle S is going to be equals to 180 degrees minus by 2x because we are going to transpose. And then you are going to say, therefore, STOR is a cyclic quadrilateral. Why? Because O1 is equals to angle S, right? This is the reason you can state, or you can say converse, the exterior angle of a cyclic quadrilateral is equals to the opposite interior angle. So if you're having any questions, please post them on our comment section below. And if you want me to treat a certain question that you are having a problem with, please comment with the year of the paper. For an example, I can say 2018 November, paper 2, question 11, and you can even include the province if it's not a national paper. So this is what is going to happen from now on. Each and every Friday, Euclidean is our happy place. So let's go to our next video. Cheers, guys.